Welcome to WOSEN Laboratory. Let me show you the team behind the development of WOSEN lighting products. Here are our professional technicians and equipment. First visit is the reliability laboratory. In here, the drying oven and multi-channel temperature recorder simulate extremely high or low temperatures and record them to understand the service life of the products in harsh environments. Our testing of materials also includes testing for humidity. Considering that the product may be stored in special environments, in order to confirm its service life, we will simulate environments with different humidity and temperature, and connect the power supply of the lighting product for testing. This process not only includes setting temperature and humidity, but also setting the duration. The next project is the comprehensive testing of light, color, and electrical performance. We're here to test the luminous flux, color temperature, luminous efficiency, reflectivity, transmittance, and other data of lighting products. This room is used for conducting EMC-conducted radiation testing. We have professional staff and instruments to test the electromagnetic generated by the lighting products to confirm that they will not affect the surrounding electrical appliances. This step is to simulate the pulse interference generated by lightning coupling, high-power equipment startup and shutdown, and power supply failure, and test the ability of the power supply and protection devices in the lighting products to absorb surge pulses. We will also conduct electrostatic discharge testing by placing the lamp in an electrostatic environment and testing its anti-static ability by simulating electrostatic discharge. The insulation resistance between the charged parts of the product and the exposed non-charged metals is also an important detection link, which can ensure that the lamp product avoids accidents such as electric shock or damage during operation. This tester measures whether the leakage current meets the standard, observes whether the current passing through the lamp during normal operation is within the safe limit, confirms whether there are safety hazards, and avoids unnecessary harm. The same test also includes voltage withstand testing, a non-destructive test that determines that electronic insulation materials are sufficient to withstand transient high voltages, which can detect possible defects such as insufficient leakage distance and electrical clearance caused during EM. The final test about electricity is the grounding resistance test, which aims to ensure that all conductive components on the product that can be contacted by the user will become charged in the event of a single insulation failure are reliably connected to the grounding point of the power input. In addition to power-related testing, we'll also conduct physical testing of the materials of the product. Needle flame test, bringing the test object at a fixed angle of 45, observing whether the lamp material is ignited, the duration of ignition, and the length of combustion, to evaluate the fire risk of small flames caused by fault conditions inside the equipment. Similar experiments with hot wire. Heat the specified material and shift the electric heating wire with high current to the test temperature for 1 minute, and then burn the test sample vertically at the specified pressure for 30 seconds. Determine the fire hazard of the finished electrical and electronic equipment based on weather. We will also conduct waterproof tests to test the waterproof level of the lighting products. By simulating the environment of natural rainwater, it can provide realistic simulation of various situations or electronic components and devices may be splashed or drenched during transportation or use, in order to detect whether they have waterproof and rainproof functions. After testing, we will also observe the lighting product for a period of time to confirm that it has no fogging or other malfunctions.